To start off, the motor neuron releases a neurotransmitter called acetylcholine into the synaptic cleft. As the neurotransmitter binds to the receptor sites, an action potential is triggered and perpetuates along the sarcolemma or the cell membrane of the muscle cell. The T-tubule helps carry the action potential down into the cell. With the help of ATP, the sarcoplasmic reticulum is then triggered to release calcium. The calcium ions then exit and move toward troponin on the actin. Calcium ions move toward the two filaments of the sarcomere. The two filaments are the actin and myosin. As the calcium ions bind to troponin, the tropomyosin then lifts up and reveals the binding sites for the myosin heads. This is all happening in the sarcomere. As hydrolysis splits ATP into ADP and phosphate, the myosin head enters high energy configuration and binds with the myosin binding points. The head then enters low energy configuration and pulls the actin toward the center of the sarcomere, causing the muscle to contract. This is called a power stroke. ATP is then needed once again to release the myosin head from the myosin binding points. Now that you understand a muscle contraction, here's what happens during rigor mortis. The sarcoplasmic reticulum is unable to control the amount of calcium ions released, so all of them go out of the sarcoplasmic reticulum. Just like in a normal muscle contraction, the calcium binds to troponin. As this happens, the binding points are revealed as tropomyosin is lifted up. The myosin heads then bind to the binding points on the actin, and a power stroke is performed. But there's no more ATP to pull apart the myosin head to break the cross bridge, so the muscle remains contracted, causing the body to feel very rigid and stiff.